So in the atoms, the first topic is about your Rutherford alpha scattering experiment. For the atomic model, if I remember better, you might have been seen that the central part is nucleus, that is Z into your E. When electron was being, an alpha particle was being incident on this one, as the nature of the alpha particle was positive, it has been striking the nucleus, and at a certain point, it retraces the path. The point at which it has been retraced is that distance was being called as of your radius of this one. Okay. So the distance or closest distance of your approach is represented by your R0. R0 is your closest distance of your approach. So in this one, if I'm talking about size of your nucleus, first one, how do you calculate the size of your nucleus? The size of your nucleus, when energy of the particle was being incident on this one, kinetic energy is equals to 1 by 4 pi epsilon naught electrostatic energy between the alpha particle and as well as of your nucleus. Q1 is your Z into E. Alpha particle is nothing but charge is right now 2 times of E. And distance between the alpha particle and the this one is right now for me interatomic distance R1. Formula energy formula U is equals to 1 by 4 pi epsilon naught into Q1 Q2 divided by R. Electrostatic potential energy between the alpha particle and the nucleus. So simplifying from this one, we are getting the interatomic distance formula as R0 is equals to 1 by 4 pi epsilon naught into 2 times of Z into E square divided by your energy. This is right now for me your kinetic energy part of relation. So kinetic energy is equals to your potential energy. Kinetic energy formula half into M into your V square. So interatomic distance is given by the formula R0 is equals to 1 by 4 pi epsilon naught into 2 into Z square divided by your kinetic energy. And in this one, very important formula is how do you calculate number of alpha particles scattered? The number of formula is only the important beta. The number of your alpha particles scattered at an angle pi by a nucleus. By a nucleus is. Let's say, for example, this is the nucleus. Okay. When alpha particle was being bombarded on this one beta, it was being going in a straight line for a certain interval of a time. Then at a particular point, instead of going in a straight line, it started deviating from this mean path. So this deviation is represented by phi. So the how many number of alpha particles have been deviated is being given experimentally by the formula. N phi or N theta is directly proportional to 1 and inversely proportional to your sine to the power of 4 into phi divided by 2. This is the formula you need to remember. Number of your alpha particles scattered is inversely proportional to your sine to the power of 4 phi by 2. Clear? These are the two important formulas in the size of your nucleus which you need to remember by the Rutherford's alpha scattering formulas. The next one and very important in this one is about your Bohr's postulates. Bohr's postulates. For your, it is applicable only for your single electron system. This already neatly adigadu. Bohr's postulate is being applicable for what? It is applicable for your single electron system. Am I clear? Sure.
Yes,
See,
sir.
this one, if I'm talking about the first one. So what is the first law says that right now in this one? See, first postulate. First postulate says that every electron revolves in the circular orbit. This is your nucleus. Okay. And this one is your at the center nucleus Z into E. And every electron is revolving in this one. This is E minus with a certain velocity. Okay, this is the velocity of your nth orbit. First postulate says that electrostatic force is responsible for the motion. As it is moving in a circular path, I can say that centripetal force m into Vn square divided by radius of your nth orbit is equals to your K into Z into E square divided by radius of your nth orbit. So centripetal force is equals to your electrostatic force between the nucleus and as well as of your electron. So from this one, I can calculate the velocities of your nth orbit, radius of your nth orbit, that all derivations we can do from this given system. Then second postulate you see. Second postulate says that is quantization of your electron. It is known as what for me? Bohr's quantization. What do you mean by Bohr's quantization, beta? Its angular momentum is found to be constant, n into h divided by 2 pi. As it is moving in a circular path, m into vn into radius of nth orbit is equals to n into h divided by 2 pi. This is your second postulate. Clear? Then what is the third postulate, beta? You can go to the Bohr's third postulate. Anyone? Very important.
Whenever an electron jumps from higher orbit to the lower orbit, it emits the energy in the form of photon.
Very good. It will be releasing the energy. That is your third postulate. That's what I need to remember. Like say, for example, this is your higher orbit. Okay. And this one is your lower orbit. Lower orbit I'm representing by N1 and higher orbit I'm representing by your N2. If there is an electron present in the higher orbit, whenever an electron is jumping from higher orbit to lower orbit, it liberates the energy in the form of your wavelength. That means energy is given by the formula E is equals to energy of your nth orbit minus energy of the first orbit. Energy of the photon, it is emitting the photon. So energy of the photon is given by hc divided by lambda is equals to En2 minus of your En1. This is very important formulas to be remembered. Am I clear about the three postulates, beta? First postulate says that every electron revolves around the nucleus in a circular orbit and centripetal force is responsible for its motion. And second law says that Bohr's quantization, that whatever electron is been moving in an orbit, that is always found to be constant. It will not radiate the energy or not lose the energy. So for that one, L is equal to n into h divided by 2 pi. As it is moving in a circular path having the radius r, so mvn into rn is equal to n into h divided by 2 pi. And release of energy is your third postulate. Whenever an electron is jumping from your higher orbit to lower orbit, it emits the energy in the form of what, beta? Radiation. That is nothing but of your lambda. So energy of the photon is given by the formula E is equals to final energy minus of your initial energy. So E is equals to your energy of your nth orbit minus energy of the first orbit. So E energy of the photon is hc divided by your lambda. So from that one you can calculate the given condition. Clear? Now there are important formulas which are committed to memory in this one, beta. I'll write all the formulas fastly. But for your Bohr's model, which is for your one electron system. Bohr's model for your one electron system. Formula is good to know. How do you calculate the radius of your nth orbit? First one, the radius of your nth orbit. Radius of your nth orbit is given by the formula Rn is equals to n square h square divided by, this is 4 pi square k into z into e square into n. So I can say that if I take this value of all constant, n value, h value, and simplify the relation, h is a constant, 4 pi chi square is a constant, k is a constant, z is a constant. Right now, atomic number of that element I need to take right now for the given n square law, one n will be cancelling right now for me. It is your mass of the particle that will be remaining for me constant. And e square is a constant, m is also your constant, giving the atomic number. So if I simplify that value, we are getting the radius of your nth orbit is equals to very famous 0.529 or 0.53 into your n square divided by z. Unit is your angstroms. This formula you need to remember. That means radius of nth orbit is right now directly proportional to what he can ask you. Radius of nth orbit is directly proportional to n square. Radius of nth orbit is inversely proportional to atomic number. Radius of nth orbit is inversely proportional to your mass. This is very important for me, beta. And radius of your nth orbit is inversely proportional to 1 by your e square. For theoretical questions, you need to by heart them and try to remember, beta, in the radius of your nth orbit. The next one is velocity of your nth orbit. Velocity of your nth orbit. So how do you calculate the velocity of your nth orbit? Velocity of your nth orbit is equals to, did you remember the value, beta? It is 2.18 into 10 power of your 6 into z divided by n. Unit is meter per second. So I can say that velocity of nth orbit is directly proportional to atomic number. Velocity of nth orbit is inversely proportional to your nth orbit. Velocity is it depending upon the charge of electron beta? Velocity of nth orbit is directly proportional to your E square and independent of your mass beta. It is independent of your mass. That is very important. You need to remember. And third one is about your angular velocity. As it is moving in a circular path, it will be having your angular velocity. Angular velocity represented by the formula omega n. You know the formula from circular motion? V is equals to R into your omega. So omega of your n will be equal to velocity of nth orbit divided by radius of your nth orbit. If I divide both of them, I'll be getting that angular velocity of your nth orbit is directly proportional to your z square and inversely proportional to your n cube. Unit will be radian per seconds. Very important, very, very important, isn't it? So omega n is directly proportional to z square and inversely proportional to your n cube. That value you need to remember. Omega n is directly proportional to z square. Angular velocity is inversely proportional to your n cube. Okay. Then once I know the omega, I can calculate the time period better. So time period of your nth orbit. Time period of your nth orbit. What is the formula for time period? T is equals to 2 pi divided by omega nth orbit. 2 pi is a constant, so I can say that nth orbit is directly proportional to your n cube and inversely proportional to your z square. So time period of nth orbit of the electron revolving in a circular orbit is directly proportional to n cube, and time period of your nth orbit revolving in the circular orbit is inversely proportional to atomic number square times. Clear? And unit for this one will be equal to how much beta? Seconds. Once I know the time period, then I can calculate the kinetic energy and as well as of your potential energy. So I'm writing the total energy right now for this one. Total energy of your electron which is revolving in the nth orbit. It is sum of your potential energy and kinetic energy. Total energy of your nth orbit is equals to minus 13.6 into z square divided by n square. Unit is electron volt. Very important formula. Energy of your nth orbit of electron revolving in the nth orbit, total energy is given by the formula minus 13.6 into z square divided by n square and electron volt. What is 1 electron volt value beta? 1 electron volt is equals to 1.6 into 10 to the power of minus 19. Unit is joule. That means energy of nth orbit is directly proportional to z square. Energy of your nth orbit is inversely proportional to your n square. Clear beta? And it is also depend upon the charge of electron. Energy of nth orbit is also directly proportional to E square. Am I clear? Am I clear?
Yes,
Yes,
sir.
sir.
Which you need to 110% commit it to your memory beta. Otherwise, doing the problems in the shortest time will be a problem. Radius of your nth orbit is given by the formula 0.529 or 0.53 you can take. So it is directly proportional to your n square and inversely proportional to your z and inversely proportional to your mass and inversely proportional to the square of the charge of your electron. The same way, if I'm talking about the velocity, velocity of your nth orbit is given by the formula 2.18 into 10 power 6 z divided by n. Directly proportional to atomic number, inversely proportional to n, and directly proportional to your square of your electron. Angular velocity is given by the formula this one. Angular velocity is directly proportional to z square, inversely proportional to your n cube. This is what a neat also earlier basically. Time period of nth orbit is directly proportional to n cube and inversely proportional to n square. Tn is directly proportional to n cube. Tn is inversely proportional to 1 by n square. Total electron energy of your nth orbit is equals to minus 13.6 into z square divided by n square. Unit is right now for me your electron volt. And 1 electron volt is equals to 1.6 into 10 power minus 19 joule. So energy of nth orbit is directly proportional to z square, inversely proportional to your n square, directly proportional to the square of the charge of your electron. Am I clear?
Yes, sir.
And next one is energy levels. For what? For one electron system. For one electron system means example is hydrogen type atom. Okay. See, if I take the orbits right now for me, you tell me this is your lower orbit, this is your ground state. The next one is n is equals to 1. The next one is right now for me, this one is one orbit, then this one is one orbit, this one is one orbit. something like this. This is n is equals to 1. This is your n is equals to 2, n is equals to 3, n is equals to 4, n is equals to 5, n is equals to 6, go on like that one up to infinity, n is equals to infinity. Okay. Now see, tell me what is the energy of your nth orbit formula beta? Energy of your nth orbit is equals to minus 13.6 into z square divided by n square electron volt. This is your formula. Okay. Now see, if I'm talking about for n is equals to 1, hydrogen like atom means z value is equals to any of 1. Now if I take n is equals to 1, so energy of the first orbit will come out for me how much beta? Minus 13.6 into z square. You need to by heart it this one beta. Okay, if I'm taking hydrogen like atom, z value take it as of your 1. So this is your energy level. Then when n is equals to 2, it will be minus of 3.4 into z square. Then n is equals to 3, it is minus of 1.51 into z square. Then n is equals to 4, it is minus of 0.85 into z square. The next one, n is equals to 5, minus 0.54 into z square. Go on like this, up to infinity. Then tell me at infinity, what is the energy beta? E will be equal to 0 at infinity. Clear? At least by up to 5th, you need to by heart this formulas better. N is equals to 1 is known as for me. This one is known as for me ground state. N is equals to 2 is known as, this one is known as first excited state. First excited state. N is equals to 3 is known as second excited state. Go on like that. Am I clear? Am I clear? N is equals to 1 energy minus 13.6. N is equals to 2 minus 13.6 divided by 4. It is minus 3.4 z square. N is equals to 3 minus 1.51 z square. N is equals to 4 minus 0.85 z square. N is equals to 5 minus 0.54 z square. Up to 5th by anyhow you need to by heart then beta. Okay, sure. The next heading is about your excitation of your atom. Excitation of your atom. That means when electron is jumping from one orbit to another orbit, it may either liberate the energy or it will absorb the energy. That depends upon how it is been jumping. Okay. Now say for example, whenever an electron is absorbing the energy beta, so what happens, you tell me? When an electron is absorbing the energy, it will excite from lower to higher or higher to lower? Tell me what happens when electron is jumping. See for example, if I say that for electron to absorb energy, okay, for electron to absorb the energy and it will excite to what beta? Higher state only now, because it is taking the energy. So it will excite from N1 to your N2 like that. Okay, and this energy absorbed must be exactly equal to what difference between them. That is very important to be remembered better. The energy which is to be observed, the energy which is observed must be equal to difference of energy levels. Difference of your energy levels. That is, this energy observed delta E must be equal to your En2 minus of your En1. So this is the amount of energy which it should be observing to excite from the lower orbit to your higher orbit. Okay, na? Like tell me the answer for this one. If I am right now, say for example, N is equals to 1. Now I need to go to N is equals to 3. So when I need this electron to jump from lower orbit to higher orbit, how much amount of energy I need to observe? So it should be E3 minus E1. E3 value is how much better for me? What is the value of E3 you see? Energy of the third
1.5.
1.51.
minus 1.515 minus, this is minus of 13.6. So it is minus 1.51 plus 13.6. So it will be equal to how much beta? 12.09 electron volt. So if electron is observing this much amount of energy, it will jump from n is equals to 1 to n is equals to 3. Am I clear?
Yes, sir.
That is the way how do we get some problems related to the absorption or excitations, right? The next one is about your wavelength of emitted photons. See, whenever an electron is jumping from higher orbit to lower orbit, I told you that it will be emitting the radiation in the form of what? Electromagnetic wave, that is energy of your photon. Like say for example, this is your higher orbit and this one is your lower orbit. This is N1 and this one is N2. An electron is jumping from your higher orbit to lower orbit. Whenever an electron is jumping from higher orbit to lower orbit, what I told you, it will be liberating the energy in the form of what? Energy of your photon. So here there is an electron and this electron is jumping from higher orbit to lower orbit. So it will emit the energy in the form of what? E is equals to hc divided by lambda. Okay, now write the energy level for this one. This E will be equal to En2 minus of your En1. Energy will be equal to hc divided by lambda, that is equals to En2 minus of your En1. So if I simplify this value better, I'll be getting 1 by lambda is equals to very famous formula R into your Z square into 1 by N1 square minus 1 by N2 square. Because I removed the minus sign, that is the reason I'm getting N1 minus of your N2 particulation. This is very important formula for doing the numericals when electron is jumping from one orbit to the another orbit. R is known as what beta? Rydberg's constant. Value of this one is approximately equal to 10 power 7 meter inverse. Am I clear? Am I
Yes,
clear?
sir.
Sure.
Yes, sir.
De Broglie's wavelength. This lambda will be equal to how much for me? 12400 divided by delta E. Provided the energy is in electron volt and wavelength is in your angstroms. Clear? Or else I can even write this one. Lambda is equals to 1240 divided by delta E. If delta E is in right now for me, electron volt, no doubt, but wavelength is in nanometers. Then we'll be using 1240. Clear? That means ultimately, whenever I'm calculating the energy, delta E is equals to 12400 divided by wavelength in angstrom. And unit of this one is electron volt. And 1 electron volt is equals to how much beta? 1.6 into 10 to the power of minus 19 joule. Am I clear?
Yes, sir.
So whatever we have doing right now in this one, next one is energy radiations, excitations and energy levels. Whenever an electron is been jumping from one orbit to your another orbit, the energy levels for the different states is how much? That is for the ground state it is minus 13.6, n is equals to 1 minus 3.4, 3 minus 1.51, 4 0.85 and 5 0.54. 5 and 5 you try to remember better. For 4 it is double. 4 is right now for me double 8. Then right now 3, it is right now for me 5. Like that you try to remember for the fifth one and as well as of your fourth one. Excitation of electron. For an electron to absorb the energy and excite from where? N1 to N2, lower orbit to higher orbit. This energy absorbed must be equal to what beta? Difference of your energy levels. That is delta E is equals to En2 minus of your En1. Clear? Like see here I told you when it is jumping from lower orbit to higher orbit, the difference must be equal to how much beta? E3 minus E1 U2. If it is like from 1 to 2, then E2 minus E1. Like that you try to take. Then wavelength of the emitted radiation beta. It is given by the formula 1 by lambda is equals to R into Z square into 1 by N1 square minus 1 by N2 square. Hydrogen like atom, Z value is 1 and value of R is 10 power 7 meter inverse. How do you calculate the wave energy beta? E is equals to 12400 divided by wavelength in angstrom. Unit of the energy is electron volt. In nanometer, it is 1240 divided by delta E. That much you need to remember. Am I clear? Any doubt in this one to anyone?
No doubt, sir.
Sure. So tell me the relation between the potential energies beta in this one. Keep a note and try to remember this relation also beta. Minus of your total energy will be equal to your kinetic energy. And this kinetic energy will be equal to minus of your potential energy divided by 2. This relations he will be asking. Kinetic energy, potential energy and total energy relation. Clear beta? Am I clear?
Yes, sir.
Sure. What happened to the mass of electron beta when it is revolving? It is always remaining for me or constant. Am I clear?
Yes, sir.
Sure. See this question beta once. What is the angular momentum? What is the angular momentum of an electron in your Bohr's model? In your Bohr's hydrogen atom, whose energy is minus 3.4 electron volts. Come on, try to do it. Anyone? What is the angular momentum of electron is asking when energy is already given for me. What is energy given for me? Minus 3.4. Energy formula beta E is equals to minus 13.6 divided by hydrogen like atom Z value is 1. So it is N square into electron volt. Energy is given right now for me minus 3.4. That is equals to minus 13.6 divided by N square. Isn't it? So how much are we getting the N value beta from this one? Is this minus will get cancelled. N square is equals to 13.6 divided by 3.4. So how many times it will go? Anyone?
Four times.
4 times it is going. 3.1 and this one is 4 times. N square value is 4. That means N value is how much for me? 2. If N value is 2, can I calculate the angular momentum better?
2h by 2 pi.
Second law. Angular momentum. L is equals to N into H divided by 2 pi. So what is an angular momentum? N value is how much for me? 2.
H by pi.
Into H
H by
divided by
pi.
2 pi. So this will be equal to how much for me? H by pi will be the angular momentum. Am I clear?
Yes, sir.
Sure. This question also very famous. Calculate the ratio of maximum to minimum or minimum to maximum, anything right now. Maximum to minimum or minimum to maximum, anything. Maximum wavelengths of radiations that an electron causes in Bohr's hydrogen atom. Okay. Condition is if electron is de-exciting to your 1. If the electron is de-exciting to N is equals to 1. So try to do it. Maximum to minimum or minimum to your maximum. 1 by lambda max, if I'm writing the formula better, 1 by lambda max is equals to R into, it is coming to the 1, so it is 1 square minus, from where beta maximum, second orbit, 2 square. Clear? Then for minima, can anyone tell me? 1 by lambda minima will be equal to again R into, this will be equal to, N1 is coming to the first orbit. When it is lambda minimum, that means it should be your infinity. Isn't it? So if I take the ratio of this one, lambda minima divided by your lambda max, that will be equal to 1 minus 1 by 4 divided by 1. So this will be equal to 3 by 4. Clear?
Yes, sir.
Am I clear? Maxima means from second to first beta. If nothing is been mentioned, if it is mentioning any time, then that value we need to take. He's just asking us to calculate the ratio of your minimum to maximum or maximum to minimum wavelength of radiation that an electron causes in the Bohr's hydrogen atom if the electron is exciting to the 1. These are the different energy levels. No? It is n is equals to 1, n is equals to, this is right now 1, n is equals to 2. 2 నుంచి 1 వచ్చింది అనుకోండి, this will become for me your maxima. If it is coming from infinity to your 1, this will become for me minima always. Am I clear?
Yes, sir.
Chalo. This one is also one of the important question. Better see. Say for example, we got an energy of 24.6 electron volt is required to remove one of the electrons from a neutral helium atom. Okay, what is the condition? Energy of how much better? 24.6 electron volt is required to remove one of the electron from the neutral helium atom. The condition is right now for me, the energy in electron volt required to remove both the electrons from a neutral helium atom is. Can anyone try it better? I'll give the options: 79.0, 51.8, 49.2, and 38.2. Read the question carefully first. The energy of 24.6 electron volt is required to remove an electron. Now tell me, the energy of an helium will be equal to how much better? Energy of your helium will be equal to 13.6 into Z square. That is equals to 13.6 into Z square is 2 square. That is 4. 13.6 into 2 square is 4. So this will be equal to how much for me? 54.4 electron volt is being present in the lowest or level of your helium. And total energy required to remove this electron is how much better? How much energy it is already having? 24.5. I can say that total energy needed to remove both the electrons from helium will be how much better? Already it is having 24 and in ground state it is having 54.4. So obviously it will become how much for me? 79 point something I can take. That means the best option I can write is 1 electron. Clear?
Yes, sir.
See once again, but any doubt in this question, let me know. Sure. Do this question, everyone. Take a pen and paper and try to do it with a faster. Now tell me, energy required per the electron excitation in lithium double plus from first to the third orbit. First to the third Bohr orbit is. So faster. I'm giving the options: 36.3 electron volts, 108.8 electron volts, 122.4 electron volts, and 12.1 electron volts. Faster. Energy required for the electron excitation in lithium double plus ion beta. From the first orbit to the third Bohr's orbit will be equal to your how much? Energy formula is what beta? Delta E is equals to 13.6 into your Z square into 1 by N1 square minus 1 by N2 square electron volt. Okay. So this will be equal to 13.6. Atomic number for lithium plus is how much better? 3 square into first orbit is right now for me 1 square. From which orbit? Third orbit. It is your 3 square electron volt. So this will be equal to 13.6. 3 square is 9 into 1 square is 1 divided by 1 minus 9 electron volt. See how much I'm getting this one. How much?
103.8.
How much better?
108.8.
Okay. 108.8 electron volt. Got it, everyone? Sure. Next question. This is good question. Keep a star mark and try to do it better. Like say, for example, an electron of a stationary hydrogen atom passes from fourth energy level to ground. Okay. What is the recoil velocity? Recoil velocity of the atom as a result of photon emission. Okay. This is a question. Try to read the question carefully. I'm giving you the options. First option is 15H into R divided by 16 times of M. Second option is H into R divided by M. Third option is 13H into R divided by 15M. And fourth option is 16H into R divided by 15M. Read the question carefully. An electron of a stationary hydrogen atom. An electron of stationary hydrogen atom is passing from which state, beta? Fourth state level to the ground state. That means N1 value will be equal to how much, beta? Ground state kabatti N1 value is 1 and N2 value is equal to how much for me? 4. Clear? And is asking me the recoiling velocity of an atom, because when it is jumping from higher to lower, it will emit the radiation and it will hit an electron in the lowermost. What is the recoiling velocity of that atom? He is asking. So first calculate the wavelength. 1 by lambda is equals to your R. Hydrogen like atom, it is 1 by 1 square minus 1 by 4 square. So how much it is? 1 by lambda is equals to R into 1 minus 1 by 4 square is 16. So 16 minus 1, 15. So it is your 15 into R divided by 16 is lambda. 1 by lambda value. So 1 by lambda is equals to 15 into R divided by 16. So when this is been happening, energy of the photon is given by the formula E is equals to h nu, and momentum of the photon will be equal to how much, better? P is equals to your h divided by lambda. In terms of velocity, so it is m into v is equals to h divided by lambda. Clear? Recoiling velocity antunnadu. So this velocity will be equal to h divided by m into lambda. So that is equals to h divided by m into 1 by lambda is how much, better? 15 into r divided by 16. So velocity, recoiling velocity of this one is given by the formula 15 r into h divided by 16 times of your m. This is the way how do we calculate the recoiling velocity when an electron is jumping from n is equals to 4 to n is equals to 1 in the form of your radiation wavelength has been coming. So the moment it hits, it will recoil. So recoiling velocity is given by the formula 15 r into h divided by 16m. We may just change the orbits better, maybe from 3 to 4, 3 to 2, maybe from 5 to 2, like that. Just take that one and try to simplify the problem. Am I clear?
Yes, sir.
Any doubt in this one?
No doubt, sir.
Series Gurtunda, Lyman series, Balmer series, Paschen series,
Yes, sir.
isn't it? When electron is jumping from one orbit to your another orbit, Lyman series lies in which region, beta?
UV.
UV region. Basic chemistry lo unnade nana, same as it is. There is nothing in that one. So how do you calculate the number of your spectral lines when it is been emitting from one orbit to the another orbit? number of your spectral lines. Formula గుర్తుందా? N is
n into n minus 1 by 2.
minus 1 divided by 2. Okay. What are the possible number of photon energies emitted due to the de-excitation of electron from higher orbit to your lower orbit? Am I clear?
Yes, sir.
Sure. I'm roughly drawing this diagram. See, if electron is jumping from second orbit to first orbit. Okay, this is 1, this is 2, 3, 4, 5, 6, go on like that one. Okay, then from 3 to 1, or from this one like this. What will be this series, beta?
Lyman, sir.
Lyman series. Lyman series means n1 is equals to 1 and n2 will be greater than or equal to your 2. Antena?
Yes, sir.
So when the electron is jumping from third orbit to the second orbit, or from 4 to this one, or like this basically. This will be which series? Balmer series. Balmer series will lie in which region, beta? It will lie in your visible region. Lyman series will lie in your ultraviolet. So for this one, n1 value is how much, beta? N1 value is 2 and n2 value is greater than or equal to your 3. Clear? If an electron is jumping from your 4 to 3 right now, like this. Then 5 to 3, go on like this. This will be which series, beta? Passion series. So passion series lies in which region, beta? Infrared region. Tell me n1 value, beta. N1 value will be equal to 3 and n2 value will be greater than or equal to 4. Clear? After passion, what is the series, beta? Can anyone tell me? If an electron is jumping from 5 to 4 or 6 to,
Bracket series.
this will be your bracket series. For bracket series lies in which region? This also lies in your
Far higher.
region. This also lies in your infrared region. For this one, what is the value of your n1, beta? N1 is 4.
4.
N2 is greater than or equal to your 5. Then what is the next one, beta? 6 to 5 and go on like that higher. This will be what series?
Fun series.
Fun series. Fun series also lies in which region, beta? Infrared region. For this one, n1 value is how much for me? 5. And n2 value will be greater than or equal to 6. Clear? Yeah. See this question, beta. Tell me the answer. Ratio of longest wavelength corresponding to Lyman and Balmer series. Lyman and Balmer series in hydrogen spectrum. In hydrogen spectrum. Anyone? First option is 9 by 31. Second option is 5 by 27. 3 by 23. And fourth option is 7 by 29. Faster. Ratio of your longest wavelength corresponding to Lyman series. Lyman series means n higher value will be equal to how much better? 2.
5 by 27.
Very good. And lower value will be equal to how much for me? 1. For Balmer series, just now I told you. N higher value will be equal to 3 and n lower value will be equal to 2. Clear? So if I'm talking about for Lyman series, 1 by Lyman series is equals to R into this is 1 by 1 square minus 1 by 2 square. This is your R into 1 minus 1 by 4. So this will be equal to 3R divided by 4. This is the wavelength of your Lyman series. So wavelength of the Lyman series is lambda L is equals to 4 divided by 3R. Now if I'm talking about for Balmer series, 1 by wavelength of your Balmer series is equals to R into 1 by N1. That is nothing but 2 square minus 1 by your 3 square. So it is your R into 1 by 4 minus 1 by 9. This is the wavelength of Balmer. So 1 by 4 minus 1 by 9 means if I take the LCM, this is R, this will be 36. This will be 9 minus of your 4. This is the de Broglie wavelength of Balmer series. So wavelength of the Balmer series will be equal to 36 divided by 5R. So this will be 36 divided by your 5R. Now take the ratio of this one better. So wavelength of Lyman series divided by Balmer series. So this will be equal to Lyman series is how much for me? 4 divided by 3R into this will be equal to 5R divided by 36. This R will get cancelled. So simplify this one, see how much I am getting?
5 by 27.
5 by 27. Got it, everyone? Clear, beta?
Yes, sir.
Sure. Tell me the answer for this question. Hydrogen atom in your ground state. Good question, bro. Is excited by a monochromatic radiation of wavelength lambda is equals to 975 angstroms. I need to calculate number of your spectral lines. Number of your spectral lines. First option is 3, second option is 2, third option is 6, fourth option is 10. Anyone? Hydrogen atom in the ground state is excited by a monochromatic radiation, isn't it? When the wavelength is given, energy radiation will be equal to how much better? 12400 divided by wavelength. Wavelength is 975. See how much I'm getting this one? 12400 divided by 975 will give me the energy. And we know the energy radiation delta E is equals to energy in the higher state minus energy in the ground state. So energy in the higher state we need to calculate. Energy in the ground state we already know minus 13.6 electron volt. Delta E value ఎంత వస్తుంది చూడండి సార్. E2 minus E1 కదా. Ground state అంటే minus 13.6. Delta E value is 12400 divided by 975. ఇదంతా వస్తుంది చూడండి రఫ్గా.
12.7.
12.7. That means this is 12.7. So how much I'm getting the energy of the higher state? Energy of higher state is right now for me minus of your 13.6 plus this will be 12.7. Antena? So this is coming out for me how much? Minus 13.6 plus 12.7. The 7-1 is minus of 8-4. So this is the energy of higher state. Now tell me 0.84 is the energy of which state, beta? N is equals to 1. What is energy? Minus 13.6. N is equals to 2. Energy is how much for me? Minus 3.4. Energy is equals to 3.
Minus 1.5.
Energy will be equal to how much for me, beta?
Minus 1.51.
Minus 1.515. N is equals to 4. How much I'm getting energy?
Minus 0.85.
Minus 0.8.
5.
5. So what will be the N value for the H is equals to energy? N value will come out for me how much? 4. If N value is 4, number of spectral lines, how do you calculate? I told you formula. N is equals to your N into N minus 1 divided by 2. That is equals to how much for me? 4 into 4 minus 1 divided by 2. That is equals to 4. 4 minus 1 is 3 divided by 2. 4 3 is 12. 12 divided by 2. That will be equal to 6. Am I clear? 6 will be the answer for this. Am I clear, beta?
Yes, sir.
And tell me the answer for this one, beta. The energy of a hydrogen atom. The energy of your hydrogen atom in the ground state. In the ground state is minus 13.6 electron volt. Okay. The energy of helium plus ion in the first excited state. In the first excited state will be. This is important, beta. What do you mean by first excited state? Anyone?
N is equals to 2.
N is equals to
Equals to 2. Very good. N is equals to 2. So energy E is equals to minus 13.6 into what is the
Minus
formula?
3.4.
Z square divided by N square. Yeah. Minus 13.6. Z value is how much, beta? Helium kabatti. Z is equals to how much for me? 2. N is equals to how much for me? 2. So it is 2 square divided by 2 square. This will get cancelled. It is minus 13.6 electron volt. Clear? Done, beta?
Yes, sir.
And there are very good PYQs even in this chapter, beta, based upon some of the basics of your wavelength lambda. ఒక్కసారి తీసేసి PYQs ఒకసారి కంప్లీట్ చేయండి. That will help you out for doing the revisions of this one.
Okay, sir.
I'm sending you one assignment, beta, right now. So please try to complete that all questions at any cost.
Okay, sir.
గ్రూప్ లో వచ్చిందేమో చూడండి ఒకసారి. ఖచ్చితంగా ఈరోజు అవి అయిపోగొట్టాలి at any cost.
Okay, sir.
చూసుకున్నాను ఒకసారి గ్రూప్ చేసేయండి. Open your group and see the questions related to that one.
వచ్చింది, sir.
వచ్చిందా? Sure. So please try to complete that questions of your atoms. Okay. And today in the night session, we'll try to complete your ray optics topic, silvering of your lenses and compound microscope, simple microscope, and their applications. And some of the formulas related to your combination of your mirrors and slab problems, better slab and mirror problems with some shortcuts. Okay, na? ఇప్పుడు పంపించిన అసైన్మెంట్ కంప్లీట్ చేయండి అందరూ.
Okay, sir.
టేక్ కేర్. Bye.